Hi everyone. I wanted to record a geometry review video for everyone for some brief crash course on some of the formulas you need to remember before taking the test. So in this particular video we're going to cover basic formulas and information for four-sided shapes that includes squares, rectangles, parallelograms, and trapezoids, as well as circles and triangles. And if there's one part of this that you're going to watch, really focus on the triangles one because it is the most heavily tested shape on the ACT. So let's get started. So four-sided shapes might include squares and rectangles, which I know everyone knows what those look like. That's pretty straightforward. But the facts that you need to know about squares and rectangles are they have four 90-degree angles. Those angles always add up to 360 degrees total. And opposite sides are parallel. And opposite sides are equal. So in the case of a square, which has four equal sides, that's pretty obvious and straightforward. For a rectangle, the opposite sides are obviously equal. To find the area, you just multiply length times width, or as the case may be, base times height. They really kind of mean the same thing. So that's easy and probably something you remember already, but just in case, I'm going to throw it in there. A little more esoteric shape is a parallelogram, and its square equivalent, the rhombus. So a parallelogram looks something like this. Okay. And a rhombus looks something like this, where you have the either a square or a rectangle slightly shifted, so it looks a little bit lopsided. So the definition of either a parallelogram or a rhombus is opposite sides again are parallel. That should sound familiar. Sides are parallel and equal. A rhombus has four equal sides. That's why it's like the square. However, the angles are not all 90 degrees. Angles not 90 degrees. Okay. But the opposite angles are equal. So, for example, on this parallelogram here, this angle and this angle would be the same. And I know my drawing is not so great and they definitely do not look the same, but if it is a parallelogram, they are. And then this angle and this angle are the same. Okay. The way to find the area of a parallelogram or rhombus. Let me go back there. It's not what I wanted to say. You'll do this slightly the same as a rectangle square, but also slightly not, and there is one little tricky part. So here's another parallelogram, and to find the area, you're going to multiply base times height, which is pretty similar to that whole length times width thing for a rectangle. However, the difference is the height is not the length of this side. It's not. So it is, however, the vertical distance. So this needs to be a 90-degree angle. That is the height. Okay. So the, again, area is base times height, but it is the vertical height. Okay, and that applies to the rhombus as well. Okay. The last kind of funny four-sided shape that the ACT likes to test is the trapezoid. Okay. And trapezoids look something like this, where you have two parallel sides and then two not parallel sides. And you can't really say anything about the sides of a trapezoid having any kind of relationship to each other. So you can have essentially a regular trapezoid that kind of looks like that one, where this side and this side appear to be equal. But you can also have a trapezoid that looks something like this, where clearly those two sides are not at all equal. So there's not too many absolutes when it comes to what a trapezoid looks like. But there are a few rules. The two base sides are parallel. So the top and the bottom, this one and this one, are parallel, and that's important to know because sometimes angles have something to do with things. All of the angles of a trapezoid add up to 360, just like all of the other four-sided shapes. And the formula for the area of a trapezoid, which the ACT does like to test, is this. Base 1 plus base 2 divided by 2 times the height. Okay. And again, it's the vertical height. So if I draw this on here, that's the height, not the length of one of the sides. Okay? So that's all the basics of the four-sided shapes. Next big shape that the ACT likes to test is the circle. But there are really only two formulas you have to remember when it comes to a circle. So let's draw one here. Okay. And probably most of you remember that the distance from the center of the circle to the edge is called the radius. Okay. And the diameter is the distance all the way across the circle through the center, which is really just 2 times the radius, but that's called the diameter. Okay. And there are 360 degrees in a circle as well. There's kind of a continuing theme here. So the two formulas you need to know are, one, the area, which is pi r squared, and r is the radius. And one way to kind of keep that straight in your head is that area is always measured in square inches or square feet or square miles or whatever. So that can be an indication if the question indicates, what is the area of this circle measured in square inches. That might be a little reminder that, oh yeah, there has to be a squared in the formula that I'm going to use. The other formula is the circumference. And that one is 2 pi r, or that can be expressed as pi d, where d is the diameter. So, because 2 times the radius is the diameter, remember? Circumference is a measure of length, so it's always going to be expressed in inches, feet, miles, centimeters, whatever. And circumference is the distance around the outside of the circle. So it's kind of like the perimeter of a circle. Okay. Finally, let's get to triangles, and this is kind of the big one. Triangles are by far the most heavily tested shape. Okay. Here are the facts you need to know. Obviously, triangles have 3 sides. That's pretty straightforward. Okay. This one I'm drawing kind of like an equilateral triangle. And an equilateral triangle is one where all of the sides are equal and all of the angles are equal. So an equilateral triangle has equal sides and equal angles, which means those angles are going to be 60 degrees. The lengths could be anything. But you could also have a triangle that looks kind of like this one. And let's say that that one's a right triangle, right? You could have one that kind of looks like this one, which we'll call an isosceles triangle, where these two sides are equal, and that also indicates that these two angles are equal when it comes to triangles also. Okay. Angles add up to 180, which I think I already mentioned. Okay. 180. Okay. The formula that you need to know for the area is 1/2 of the base times the height. And again, that's going to be the vertical height, so that's kind of a continuing theme. If it's a right triangle, then this side would be considered the height, so that's pretty easy and straightforward. However, if you're talking about any other kind of triangle, the height will be the vertical height from the highest point down to the base. Okay. Formulas that have to do with triangles, the Pythagorean theorem, which everyone probably remembers, but it may not always occur to you to use it. It only works for 90-degree angle triangles, so a right triangle is the only type of triangle you can use the Pythagorean theorem. But it is a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the hypotenuse. And the hypotenuse is the side that is opposite the 90-degree angle. So on this triangle, it would be that particular side. All right. And then the legs are the other two sides. There's also something called a Pythagorean triple. And this one is almost like a bonus point one, but if you notice them, you can save yourself some grief. And Pythagorean triples are special right triangles where the sides are whole numbers. So no square roots, no decimals, no nothing. One of them is a 3, 4, 5 triangle where one leg is 3, another leg is 4, the hypotenuse is 5. But you might also see multiples of that. So you could see a 6, 8, 10 Pythagorean triple with all of those sides multiplied by 2. So 6 is 2 times 3, 8 is 2 times 4, 10 is 2 times 5. You might also see 9, 12, 15. And even though if you are given a right triangle with two sides and maybe you're given the two legs 3 and 4, if you're really swift and you remember the Pythagorean triple, you will know that the hypotenuse is 5. But if you don't, it's not the end of the world. The Pythagorean theorem will always still work. It just takes a little bit longer and is a little bit more effort. So I like shortcuts. The other Pythagorean triple, which you are most likely to see, is a 5, 12, 13 Pythagorean triple, where the short leg is 5, the long leg is 12, and the hypotenuse is 13. And you don't really see multiples of that one. I want to say maybe I've seen one once that was a multiple of that, but most often it's just 5, 12, 13. So that is all of your geometry formulas in a nutshell. Hope this was helpful and best of luck on your test. Thanks.